Next up, we have another speaker from the Alexander Institute, that's Frederiksen, who will talk about HedaX, the health data exchange. Over to you.
Yes, thank you. Thank you for the introduction. So this is joint work with my colleagues, Jonas Lindström from the Alexander Institute and Benny Pincus from Bailan and Nikolai Vukushev from Pleo. And before I start going further on, I just want to give a word of warning that this is very much bleeding edge work in progress. So first, a little bit of shameless advertisement / setting the stage. So I'm from the Alexander Institute, which, for those of you who don't know it, is basically a non-profit organization in Denmark, whose goal is to bridge the gap between the academic community and the commercial space within computer science. So we have different labs looking at different areas of computer science and try to get this out into something that will actually be used in the real world. And I'm with the security lab, of course. So that's just a bit of setting the stage about who I am and what we are here. So this talk will be talking about the Health Data Exchange project. I will just start by describing a little bit exactly what this project thing actually is, and then a bit more about what this talk will be about, like from the more cryptographic point of view. Where we'll give a few protocols and for solving a project problem in relation to this project. And then I will give some concluding remarks and further points that needs to be addressed to fully obey this overall project. So let's address the elephant in the room. What exactly is this project? So the project description mentions the following, which is a bit long, but basically from it we can extract a few keywords that we basically need to prevent something privacy preserving, confidential, that's scalable for all data with relevance for health in Denmark. Furthermore, this data should, again, privacy preserving and confidentially be usable to compute some functions for several societies, business, research institutions, and so on. So what we gather from this is basically this project considers the real world setting, or in this case now model, where we have basically a vertically shared database between different organizations containing data on every single citizen in Denmark. So basically it means that we have different governmental institutions, we have health authorities and so on. Each have some data on every citizen in Denmark. And basically what we want to do is we want to combine all this data in such a way that it allows for privacy preserving and confidential queries on this data by businesses, research institutions, and so on. And finally, the last keyword I also want to mention is that this should, of course, be consensual. So every citizen whose data is being used in a computation should be able to give consent to do this, even though the data itself will be used in a privacy preserving manner. So the project itself is a large research project that's sponsored by Innovation Fund Denmark, which is an innovation fund here in Denmark. Surprise, surprise. It's 2 years in length, and it's basically just started, and it will result in a production level solution. So this is something that's actually going to be used in the real world to compute on real data. It sprung out of 2 large research projects. First project was one called Big Data by Security, also here in Denmark, which had the goal to use MPC to do statistics on big data sets, such as credit rate benchmarks or energy consumption benchmark. The other was the research project my colleague Mads just talked about, SODA, the EU Horizon 2020, so pretty typical research and innovation action project, whose focus was on oblivious computation over large data with emphasis on health. So the HedaX project involves a lot of different partners. Most of those will probably be unfamiliar to most of you. And that's quite interesting because a lot of these partners, as I've tried to color coordinate, is considering medical or data companies, data rights companies, or governmental organizations. So basically most of the people involved in this project are here with the data, with an infrastructure, with database, with consent, and all those things needed to actually deploy things. And the two partners here that are that have expertise in, say, MPC and development is HedaX and the Alexandra Institute, where HedaX is an Aarhus MPC business that is basically actually doing taking MPC and secret sharing into a real world setting. So with all this in mind, basically what this project aims to do is to construct a framework that allows for privacy preserving and consent requiring service to do statistics on a very large confidential health database that is held between different servers. And this will be implemented based on the MPC framework Fresco, which we've developed at the Alexandra Institute, which is implementing speeds and different flavors of speeds. So that in mind about the overall project, let me just tell a bit about where the more interesting MPC challenges are, as I think this is more that's more relevant in this setting than talking about different data providers. So for today, I will consider specific setting for doing this HedaX project. Basically, we're considering the two server settings. So we consider the setting where the database is vertically distributed between two servers here in this country, where each server contains a row of every citizen in Denmark. But of course, the columns, like the specific types of data, the specific values, will be different between these two servers. We want to consider this, the setting where an arbitrary amount of clients basically come in a series or in parallel, whatever, to do some computation on a subset of this Danish population. So just for reference, those who don't know, in Denmark we have about a little more than 5.5 million citizens. So we're talking very big, at least I would say very big databases. For the purpose of this talk, we consider like a bit more of a lenient security goal, such as semi-honest correctness, but malicious privacy. And we're putting a pin in the consent aspects and assume this will be handled out of band instead of the cryptographic solution. So since we basically have a bunch of different clients, we have some servers, we have some citizens, it's not completely trivial how this all works in an MPC setting. So let's consider for a second what we actually want from such a solution. So in regards to privacy, of course, we want to hide the data from one of the big data providers towards the other, and from both of them towards the client. We also want that only the client learns the output. We don't want these data provider gaining too much information. In regards to correctness, I mean, we want a typical definition of correctness, but in this case, and in MPC in general, you know, we have the potential issue of input substitution. So basically, what we want in this setting is that at some point in the beginning, before the clients come along, basically the servers commit to the input for all the citizens, and then they can't change it after they see this and this client comes along with this and this query. So this basically means we're in a setting that's really excellent to do some sort of function-independent preprocessing, MPC, which is you know, exactly what we can do with speeds. So if we assume, I'm going to argue why this is not the case, but if we just for the sake of argument assume that these privacy and correctness things I mentioned a second ago are enough, then what could we do? Well, we could say we have an MPC box, and we have two databases. We have the two servers database with the same indices, one here and one over here. And basically what we then want them to do is just to input the data into an MPC computation, and then at some point a client comes along and has a request for a function to be computed, and a subset of indices this function should be computed on. So you can give this to the servers, and they can simply run this in the MPC as public information. At the end, the result will come back to these servers, which they will pass on to the client. And to avoid the servers from actually learning the result, we can use outsourced NPC, which has been worked on a few years ago, where there are some standard approaches, such as this one by Damgaard et al. So this seems pretty great because we get the privacy we wanted, we get the correctness we wanted within this setting. But when we think about it a bit more and how this is actually applied, it's not enough. The reason being that now these two servers, they learn whatever indices every client wants to compute on. And even though this can just be considered meta information, as we get told time and time again, is also still information. In particular, in a setting like this, even if these identifiers are pseudonymized, a specific person like me could be, or you could be involved in many different computations. Thus, first of all, allowing to find your identity. Second, finding a lot of information about you might not want to share. So this could be, for example, if we have a person who has been to an STD clinic, who's a member, who's going to as a customer at a certain sex shop and has a kindergarten in Nørrebro in Copenhagen, then it might be possible with this knowledge of all these different clients computing on this specific person to first of all find out who that is and then make some interesting connections based on who these clients are or who these companies are he has been to. Of course, as I mentioned, this is all going to be based on consent, so he might not consent to being part of the computations of the STD clinic or this section where he's a customer, but he's fine with being part of the computation for the kindergarten where his kid go. But this just even further proves that it's quite essential to be able to use this in a usable setting, that we need to actually hide not just identifier, but even pseudo identifiers of the people that would be computed on. So how are we going to do that? There's different approaches we can think of. I mean, like the boilerplate one would basically just be to now say that we run a three-party MPC computation with the client every time a new client comes along. It's pretty straightforward. We just use our MPC box. Done. The problem is this requires the client to do MPC, which we normally would say, yes, of course it does. That's not a problem. We know how to do MPC. But what we actually want to do here is a real service, a real applicable service for companies or researchers that might not be MPC people. So this is basically means we want to apply this in sort of a web service setting. So, and running MPC in JavaScript is really not something I want to do. And I think very few people would desire to do that. Secondly, we have the issue that even if we do this, if we want to hide the indices, now we have the problem of needing to obliviously access the right elements in these huge databases with millions and millions of rows. And it's going to take a long time in MPC. We could fix the problem of the client doing MPC by using the approach I previously mentioned of outsourced MPC. It's easy to implement. It's efficient for the client, but again, we have the issue of oblivious access of a huge database. So this is why we are coming up with a new solution to fix this and allow obliviously accessing data in a big database. So as a stepping stone, we will consider this following protocol. So basically, let's just focus on one server at this point in time. So we focus on this one. What the server does is it picks a random seed for a PRF, and it picks a random permutation, permuting all the entries in the database. And then what it does is it uses the PRF and the index of each element in the database to compute a one-time pad the data, then use the permutation to permute it. And it sends this permuted database to the other server, and it sends the seed and the permutation to the client that comes along. The client can then use the indices in the set it wishes to query to compute the padding, and it can then use the permutation to compute the permuted indices. It can then send the permuted indices to the other server, use outsourced MPC to give as input its padding. Then the two servers, they can run MPC using the public function. And this other server here will basically just input only the indices that was given by this client into the MPC computation. And the actual data is hidden towards this server because it's padded and permuted. And since it's permuted, knowing these permuted indices doesn't leak anything. Then it can be unpadded in MPC. And finally, to get the data from this one, we just do the same, and then return the output as a outsourced using the outsourced MPC approach. So, as a stepping stone, we actually implemented this approach as part of the SODA project with a nice little web interface, as you can see here, where you basically just plug in a CSV file of indices of people this is a simulated database of a couple of million entries, and the CSV file I think is about 100 entries. Then you pick a function. Up here you can see it's computing a correlation of two different columns on these indices. Then this is done on the server, and the result is coming back, being presented in the web client. You can also compute a linear regression based on some indices. And similarly, the result will be computed on the server and returned to the client once it's done. Okay, so that's all nice and good. We keep simple symmetric computations outside of the MPC. There's low communication and computation, and it's basically only dependent on the amount of queries the client wishes to access. So we can step out of this whole problem with the big database. The problem is this is only semi-honestly secure, and in fact, it's very semi-honestly secure in the sense that the client now basically has some toxic waste. It has the seed for the PRF and it has the permutation, which means if it sends that to the other server, we basically break all the privacy of the first server's database. Secondly, with this approach, we must execute a padding and permutation of the database for every new client that comes along. And we want to run this as an online service, and this is actually going to be a huge overhead. So this has some issues. Fortunately, they're relatively easy to fix. So first, to remove the issue of the permutation, sharing the permutation with the client, we can use private information retrieval instead. And to remove the PRF seed, we can use a lightweight symmetric encryption in MPC instead. This again only yields us a semi-honest, although now private in case of malicious attacks. And thus we can, in that case, we can then use pretty standard transformations and checks such as max and linear combinations to ensure we can get malicious security. So what the protocol now looks like is that the first server encrypts, picks a random key, encrypts every row of the database using this key, using a MPC lightweight cipher. It's a cipher that can be run efficiently in MPC, such as MIMC. And then it sends this encrypted database to the other party. So now both this server and this server can input the encrypted database into private information, the private information retrieval protocol. And the client can input the indices it wishes to learn and then learn the result. So basically, just a quick word for those who are not super familiar with private information retrieval. It's basically a protocol that, as the name suggests, allows someone to privately retrieve some information, meaning that you have some server or multiple servers holding some data you want to access. You don't want them to know what you access. So the data itself is not secret. So this also means that this might leak a lot of information on other data points that you don't want to access. This can be done both with a single server or multiple servers. If we have multiple servers, it can be done quite efficiently with information theoretic primitives. So in a case like this, it can be based on XOR. and will result in sublinear communication. That's why we want to use this. I mean, the trivial solution would be to just send the whole thing to the client, but we don't really want that. Like before, this is just focused on doing it for one of the servers. So we switch the roles, do it for the other servers, the other server. And then at the end, the client can publish the function it wishes to compute and give the encrypted input to the MPC computation using outsourced MPC. And the computation can then decrypt it, and they can run the computation and return it to the client in an outsourced manner. So what's still missing? I mentioned that this is still only like semi-honest. It's possible to make this go incorrectly. So you need some checks on top of that. And as I mentioned, we wanted to do this with a consent mechanism. This is going to be a bit more complex, but we have an idea of how to achieve this based on digital signatures using randomizable public keys to allow basically to allow citizens to sign that they give their consent, and then have the servers verify this, but in a way where the keys get randomized in such a way that it can be verified outside of MPC, but without leaking which specific client actually gave consent, also which specific citizen gave consent. So basically, to conclude, based on this approach, we achieve a lot of what we actually want. We get to the setting where we have a setup phase, no matter how many clients we have come by, which the servers execute and is linear in communication and requires linear amount of symmetric encryptions of the data. Then per client, say who accesses M elements, using the private information retrieval approach, this gets down to O of M times square root of N communication. We have some optimizations that we can use in the setting to get it down to O of square root of M times N. It can also be lower, but then you need using some other approaches, but then you have a bit higher amount of computation you need to do. Although there's a new Eurocrypt paper we need to look at that does this even better. We get down to then only requiring for the servers. It still requires some linear computation, not communication, but computation in order to actually do this private information retrieval, since it must be oblivious to which entry that actually gets retrieved. And we do still now need to, for each element, need to do a symmetric, although we can use a lightweight cipher, computation in MPC. For the client, it's still pretty lightweight what it actually needs to do. It doesn't need to do any heavy MPC stuff. And the communication gets down also for the client to O of the square root of M times N. But again, as I mentioned, this is a work in progress, so the numbers might change. But anyway, to conclude, what I've tried to present here and what we also want to achieve in this HedaX project is basically a real-world setting, real-world framework for allowing to do privacy preserving, basically MPC as a service on very big aggregate data. So the goal here is to hide access patterns on a large database and allow to do computation. Then eventually also allow this to integrate with consent from the data subjects. And yes, that's basically it for what I wanted to say for now.
Thanks very much for the nice talk, Tom.
Thank you.
So I don't see any questions on the Q&A right now. Write them out now if you have any. Nothing's coming up. I was just wondering about the application that they have in mind. Is this to do queries on like a medical database that already exists based on people?
Yeah, so there's already a lot of data collected. This is not a database that's going to be constructed. Like concretely, we want to use some data from Statistics Denmark and the Health Data Authority that already has a lot of data collected on all the systems.
Mm-hmm. So given that there's already essentially, I guess, one party who owns the data, then splitting up into two extra servers is not adding any additional assumption. about non-collusion?
Sorry, hold on. There's a bunch of seagulls. Could you start again? You say, I mean, it's not exactly like one party that owns all the data. Like one of the servers will be run by one of the like the statistics Denmark, and the other will be run by the health data ministry, who each have distinct data. Even though both of those are here in Denmark governmental institutions, there's very strict rules about data sharing. Like different governmental institutions do not have access to each other's data.
Yeah.
And some of this might also, come from non-governmental.
Yeah. Okay. That makes sense. So one quick question from Christian on the chat, which is, any legal analysis done already?
No, so the project is just starting. So like this specific thing, there's not a legal analysis on, but there was a legal analysis as part of the SODA project. Although like not specifically of this case, but if it's more of a general, in general, there's a lot of legal analysis happening on MPC, and especially computation on shared data. So it is actually something the lawyers are getting involved with.
Mm-hmm. But if this is something that people might actually end up using, isn't there a requirement to do an analysis specifically for this case?
Yeah, of course. But as I mentioned, like the project itself, as I mentioned, it was based on some other projects, and this project itself is just starting now.
Yeah. But it's in the roadmap.
Yeah.
Okay, cool. So thanks, Tor, again.